Hello guys, and welcome to another video. On this one guys, we are looking at motion in one dimension but in terms of graphs. Okay, so here they say the velocity time graph of a car initially moving north is shown below. So this is our velocity versus time graph. Before we get into the questions guys, I just want to explain something that, excuse me, as we know, velocity is a vector. That means it's going to have a direction. Now here we are being told that our car is moving north, and if we check our graph has two sides to it. It has this upper part here, and then it has this other part. I'm just gonna use a different color, this part here at the bottom. Okay, so the upper part will be our positive direction. Let me change color here, raise this one. So the upper part of our graph will be the positive direction, which is positive direction. Okay, I don't know my spelling for direction all of a sudden. So it's going to be positive direction, and that means positive velocity basically. This means that the upper part is the northerly direction. Then down here is where we will have our negative direction, and that means this will be the opposite of north, which is south. So the bottom part is the southerly direction, the upper part is the north direction. Positive velocity up here and negative velocity down here. Negative velocity means opposite direction, which is negative direction in essence. Now let's get into our questions. 3.1 says define acceleration. The importance of knowing definitions, guys. What is the definition of acceleration? It is the rate of change of velocity. The rate of change of velocity. That is the definition of acceleration. Done. Now we move on to the second part. They say use information from the graph to answer questions 3.2 and 3.3. 3.2 says write down the speed of the car at t is equal to 9 seconds. This is where our time is 9 seconds. Can you see that? This is our 9 here, the one that I've highlighted. I'm just gonna remove that, highlight it again, or let me use my pointer. So this is where my 9 is. T is equal to 9. Let me just highlight it once more for people to see. Okay, this point of mine, I don't know if I am not using it right. There is my 9. Can you see it? Where is it positioned? It's positioned here. Oh, this pointer, this is where it's positioned. Can you see where it's flashing? And what is our velocity there, guys? Our velocity is 0, and that's because it's located on this line here, the x-axis. We call this the x-intercept, where y is 0 and y represents the velocity. So our answer for 3.2.1 is going to be 0 meters per second. Done. Now they say what is the direction of motion of the car at 9 seconds? What is the direction here, guys? Is it going north or south? The direction at 9 seconds, guys, is unknown, or we'll just say stationary. Yeah. Okay guys, I just noticed something here. I made a mistake. They didn't say what is the direction of motion of the car at 9 seconds, because that wasn't going to make sense. But they said after 9 seconds. So after 9 seconds, it means we are somewhere here now. We are somewhere here. And somewhere here, it means we are now below the x-axis. And I said below the x-axis, our direction is in the negative direction, which means south. That is going to be our answer for 3.2.2. The direction is going to be south because after 9 seconds our object is now moving in the opposite direction, in the negative direction to be exact. Now move on to 3.2.3. They say calculate the magnitude of the acceleration of the car during the interval of 3 seconds, or rather they are asking what is the acceleration, the magnitude of acceleration of the car during the interval of 3 seconds to 7 seconds. So between this time and this time here, between 3 seconds and 7 seconds. Look at our line, guys. How is it looking? It's looking flat. And if it's flat, it means we have constant velocity. And if we have constant velocity, what does that mean? It means we have zero acceleration. So our acceleration here is going to be 0 meters per second squared because we have constant velocity. Okay, so the fact that we have constant velocity means zero acceleration. Okay, hope that makes sense. Now let's move on to another question. 3.3 says, without the use of equations of motion, calculate the magnitude of the acceleration of the car during the first 3 seconds. Okay, let's check where we are finding this. This is the straight line that we have. Okay, and on the straight line we are supposed to find the acceleration. How are we finding the acceleration? We will use gradient. Okay, so let's do that. Now we have to firstly find our points. I'm gonna have this point, the starting point, and also the end point here. So that means the starting point is 0 and 0 because our object is starting from rest. The time is still 0, it hasn't moved, and the velocity is also 0, but it moves after 3 seconds, or rather after it has moved for 3 seconds, it has reached a new velocity for 3 seconds or after 3 seconds. So our x value here on the second point is going to be 3, and our y value is going to be the velocity that is now reached, which is 30 meters per second. So our 2 points are 0 and 3 and 30. We will use these points to find our acceleration. So our acceleration will be found by using the formula A is equal to Vf minus Vi, meaning final velocity minus initial velocity, divided by the final time minus the initial time. What is our final velocity? This is our final velocity here. This will be our Vf and this will be our Tf. This side, this is going to be our Ti, and this is going to be our Vi. So our Vf, guys, as you can see, is going to be 30 minus our Vi. What is our Vi? It's 0 divided by the Tf, which is the final time, that is 3 seconds, minus the initial, which is 0. Now we are saying 30 divided by 3, and what answer are we getting? The answer we get there is going to be 10 meters per second squared. Okay, they said we must find the magnitude. If they say find the magnitude, means direction is not considered. We don't care about direction. I hope you understood that. Now we move on to 3.2.2. 3.2.2 reads as follows. It says we have to find the total displacement. How do we find our total displacement, guys? Well, we have to find the area of our graph. That's how we are finding our displacement, by looking for the area of our graph. Okay, let me just get my eraser. And if you notice on our graph, we have how many areas or how many shapes? We have 3, 4. So this is 1, 2, 3, and 4. Those are the shapes we have on this graph, and I'm going to highlight them separately. We have A, we have B, we have C, and we have D. Those are 4 shapes. So we are going to look for the areas of these shapes. So what we'll say here is that displacement is equal to the area of the graph. That's the first thing we'll say, that displacement is the area of the graph, and then from there we are going to find our what are we looking for? Our areas. We'll start with the first one. So I'll see the first one is half base times height, plus the second one is going to be, this shape is a rectangle, so that's going to be length multiplied by breadth, plus another triangle, so I'm going to have half base times height, and then another triangle which is half base times height. And now I'm going to substitute. This is A, this is, okay, let me just fix that, fix my A. So this is triangle A or shape A, this is B, this is C, and this is D. Now let's find our areas. So I will have half multiplied by the base of the first shape, which is A, and we can see the base is this lower part here, the x-axis, which is 0 to 3. That means my base is 3. I can always also find it by saying 3 minus 0. So biggest number minus the smallest, I will still get 3. The height is going to be me moving from the x-axis up until the top point of my graph. In this case, I was moving from 3 up until 30 meters per second. So that means our height here is 30. Plus, what is our length? Our length will always, I normally say length is the longest side. The longest side is between 3 and 7 meters. So I ask myself, what is 7 minus 3? Just for me to find out what is the gap here. I'm going to say 7 minus 3. And the answer I'm going to get here is 4 multiplied by the breadth, which is, okay, this is vice versa, guys. Okay, the breadth is supposed to be 4 and the length is supposed to be 30, but because we'll get the same answer, it won't matter. Remember that for my height, I'm moving from this position up until this one, which is 30 meters per second. So I'm going to write that here, plus I have half base. This is now the triangle on C. Now for me to find out what my base is, I have to say 9 minus 7, big number minus small number. 9 minus 7 gives us 2 meters per second. So that's what I'm going to write here, that my base is 2. What about my height? My height is still 30 meters per second, plus the last shape, which is D, and that is also a triangle. So my base here is going to be, let me just make some alphabets or letters appear. So what we have here is 10 minus 9. What is 10 minus 9? That's a lot. Let's see, 10 minus 9. Okay, no. I was thinking something else. 10 minus 9, guys, was going to give us 1. Right? And then our height in this case is going to be what? We are moving from this point to this point. Now this is where our velocity is, and that's negative 20. We put this answer as negative 20. Okay, because we are looking here for a vector which is displacement, and it has opposite directions in this case. Then from here, guys, the rest of the work will be done by the calculator. You put all of this through the customs or rather, why am I saying customs? I mean your calculator, guys. Yeah, the brain is a bit tired now. Your calculator will calculate this and we will find our displacement. So let's quickly put this on the calculator and see what we get. All right, so guys, after putting this on the calculator, the answer we should get is 185 meters. Okay, and what is our direction? We can say to the south, okay, or not to the south. My bad. Let's say to the direction of motion. To the direction of motion. And this is how you deal with this type of question, guys. I hope it made sense. If not, just rewind the video and try make sense of it. Of course, you should also answer this question yourselves. I hope this made sense. It helped. See you in the next one, guys. Bye bye. Please like, share, and subscribe.